Welcome. We are going to be discussing and doing some calculations for ion concentrations. In each of these problems, we're going to be given how much volume. We're going to be given volume. And we're going to also be given either grams, which we will then convert to moles. So I'm going to put that here, or moles. Either way, we're going to have to get to moles. We are going to be asked to solve for how many, or I shouldn't say how many. What is the concentration? So we'll be doing this in molarity. And the way that this problem puts it is concentration of all ions present. All ions. So I will report that appropriately. We're told that each one of the substances we're going to be dealing with is a strong electrolyte, which means it dissociates completely. So these are going to be simple calculations. Okay, for our first problem, we are given the following. We are given that we are dealing with calcium nitrate, which has 1 calcium and 2 nitrate ions. So that's our substance, and we have 0.100 moles in 100.0, not 1,000, 100.0 milliliters of solution. Okay, so the first thing we're going to do, and I should have finished up here, we're given these. I'll do it down here. We're going to find the molarity of the compound. The molarity of the calcium nitrate. And molarity is moles per liter. So for our first problem, we're going to take our moles, 0.100 moles, and divide that by 0.1000 liters. Don't forget to turn this into liters. And as you can see, quite simply, the concentration of this is 1.00 molar. And that's CaNO3. 2. Okay, now, we know if we have 1.00 molar CaNO3, I could multiply this by a factor of 1 CaNO3 contains 1 Ca2 plus equals 1.00 molar Ca2 plus. I can do the same calculation, but I'm just going to, this time, put 2 nitrates for 1 calcium nitrate equals 2 molar NO3 plus. So now we were asked to find the concentration of all ions present. So the concentration of calcium was 1.00. The concentration of the nitrate was 2. Let's do our second problem. I'm going to check my camera, and it's good. Our second problem, we are given 2.5 moles of sodium sulfate. And this is in 1.25 liters of solution. So our molarity is moles per liter, is 2.5 moles divided by 1.25 liters, and that will be 2.0 molarity Na2SO4. Now in Na2SO4, we can see that we have 2 sodiums and 1 sulfate. So all we have to do is multiply, as we did in that last problem, multiply the number of each ion times our molarity to get the concentration of that ion. The concentration of sodium is going to be 2.0 times 2, 4.0 molar Na2, or Na plus, sorry about that. And for sulfate, which is SO42 minus, we're going to have our 2.0 times 1 equals 2.0 molar Na sulfate, SO4, 2 minus. And that's our answer for the second problem. In the third problem, we're given mass. We're given 5.00 grams of ammonium chloride. And I looked up the molar mass of ammonium chloride, and it is 53.49. I'm just going to put that in parentheses. So remember, our first order of business will be to convert grams to moles. And we can do that by taking 5.00 grams and multiplying that by 1 mole as 53.49 grams. The answer for this, I didn't do the answer for this. I put this whole thing into my equation. Remember, our equation for molarity is moles per liter. So what I did here is this is going to equal my moles. So I did 5.00 I put that in my numerator, and then I put my volume, which I forgot to write up here. My given volume, let me go back up here, is 500.0 milliliters, which is 0.5000 liters. 0.5000 liters. Do your math on this, and you get to 2 sig figs, 0.19 molar NH4Cl. Well, this is a substance that has 1 ammonium and 1 chloride, so the concentration of each of these will be the same. Easy. And one more. This one we have 1.0 grams of potassium phosphate. And potassium phosphate is 212.27 for molar mass. And we are given 250 milliliters solution. So again, we're going to, molarity is going to equal moles. And my moles, I'm going to do my conversion right here. 1.0 grams and 212.27 grams per mole. And then my volume in liters right here. Did I do this one? I believe I did, but it looks like I got the same answer. Let me just verify that real quick. Yep, I did. I got 0.019. 0.19 molar. So this means for K plus I have 3 ions, and for the phosphate, I'm going to move that down a line. PO4 3 minus, I have 1. So I'm going to multiply my quantity of each ion within one formula unit times the molarity, and I get 0.057 molarity for my K plus and 0.019 molarity for my PO4 3 minus. Okay, thanks.